Hello, my name is Neo Ra of Physics 2211, and this is my lab video report on Lab 5 collisions of my choice. The video contents are as you see on the screen: introduction, components of the experiment, the computer model that I used to simulate it, discussion, and conclusion. Introduction. The purpose of this lab is to simulate collision between two objects using GlowScript computer program, displaying energy and momentum principle. The related concepts and formulas of this experiment are like this: Newton's second law, which states that F equals m times a, which means that force needed to speed up or down an object is proportional to its mass. The energy principle, where you can see that the total energy is equal to kinetic plus position, the potential energy. And momentum principle, where it states that in a totally elastic collision, the momentum of the objects in collision are preserved. Here's a preview of the experiment. You will see later in the video, but you can see that the total energy is conserved and the total momentum is also conserved during the collision. The experiment consists of these components. The system is cart 1 and cart 2 displayed as the red sphere cart 1 and the blue sphere cart 2, which is sliding down a slope. The surroundings are slope, as you can see the red box, the red plate exactly, and the ground, which is green, and the earth, which is exerting gravity on all the objects. Here are the initial conditions. The mass of the two carts are 5 kilograms. The initial height is 3 meters. And as you can see, the position and momentum principles are displayed in the code, as you can see on the second and third image. And for disclaimers, this experiment is, we're going to say that this experiment is totally elastic collision, and we will see this as a point particle system. So as you can see, the cards are displayed as two spheres or points in the coordinate. Here is the video of the actual experiment being simulated. And here are the results. As you can see, the video showed that there's a totally elastic collision between two carts happening. And as you can see, the total energy is conserved. From the start, the potential energy of cart 2 gets converted into kinetic energy, and the kinetic energy of the cart is transferred totally into cart 1, which is moving forward, while cart 2 after the collision stays in place. And as you can see on the lower graph, the momentum is also preserved. The momentum increases while the cart 2 is sliding down the slope, and cart 1 gets all the momentum while cart 2 stops, therefore making the momentum 0. Discussion. The possible sources of error would be neglected forces such as drag and friction, the mistyped formulas that I could have mistaked, and non-elastic collisions. In real life, it would be non-elastic collisions. Therefore, it would exert different results. So, we see this in what-if questions. What if the collision was non-elastic? The momentum would be conserved, but not the kinetic energy. Therefore, the carts would end up with a different final speed. Cart 2 would actually be moving, presumably in the same direction. And what if the carts had different masses? If cart 1 was heavier, cart 2 bounces back, cart 1 moves forward slowly. If cart 2 was heavier, cart 2 continues forward with slower velocity, and cart 1 moves forward slowly in a velocity that is faster than cart 2. Conclusion: successfully demonstrated